class, this is Mr. Morris. We're going to do a short video on Dalton's law of partial pressures. It's really a pretty simple concept. The law basically just says that if we combine two gases together, their pressure is going to be the combination of the pressures. So we got to define a couple terms. Partial pressure of a gas in a mixture is the pressure which that gas would exert if it were the only gas present in the container. Now we have Dalton's law of partial pressures right here. It says that the total pressure in a gas is the sum of the partial pressures of each individual gas. So again, let's look at this, what that basically means. If you look at these canisters, we're saying if I have one canister, it's about this size, and we've got the first pressure of this gas. Looks like we've got 6 particles in there. Okay, and then we've got this other gas in another one. We've got 3, 6, 9, 10. We've got about 10 particles in this one. Okay, if we were to combine them together in a container of the same size, the pressure, the total pressure, will be the combination of those two pressures. In other words, our formula is basically this. Your total pressure is the sum of all of the partial pressures. So let's go down to an example problem, and I'll say this, the trickiest part in these problems is just deciding what is what. Most common mistake is a student will just assume that each pressure given is the partial pressure, but one of them is actually the total pressure. So we're going to look at a couple types of problems that you might have and make sure that we can identify the variables that we have. So if you look at this first problem, a mixture of gases contains oxygen, nitrogen, and helium. So it has 3 gases in it, oxygen, nitrogen, and helium. So let's read carefully and decide what each pressure is. This 2.10 atm, we know that that's a pressure. The pressure of what, though? The partial pressure of oxygen. Okay, that's a partial pressure. The partial pressure of nitrogen, that's our second pressure, is 0.21 atm. I'm going to turn this where I'm writing correctly. Okay, and the partial pressure of helium, that's another partial pressure, 7.80 atm. Okay, now we want to determine the total pressure. That's what it's asking for, the total pressure of the mixture. The total pressure is the sum of the partial pressures. So all I actually have to do here is add them up. It's still advantageous. It's still a good idea to go ahead and label our variables like we have for all the others. So I'm going to have P, you could call it P1 or you could call it PO2. Let's just call it P1. P1 is going to be oxygen. That's 2.10 atm. I know it's kind of sloppy. Sorry about that. P2 is going to be the next one, which is nitrogen, 0.21 atm. And P3, our third gas, helium 7.80. And then the final thing, we're going to do P total, which is just the sum of them, and we're just adding them up. So we don't know the answer yet. All we need to do to find the answer is to add them up. So P total equals, and then we're going to add 2.10 plus 0.21 plus 7.80. So after you add that up, P total, the total pressure, our answer is going to be 10.11 atmospheres. That's Dalton's law. Okay, that's a simple question where they're just asking for the combination. Let's look at the next question. Probably the trickiest way of wording this question, but you will see this occasionally. So let's kind of look at it, okay? Tells us what air is. Okay, air contains oxygen, nitrogen, carbon dioxide, and trace amounts of other gases. What's the partial pressure? So I'm looking for a partial pressure, specifically of oxygen. It is not given. That's what I'm looking for. I'm looking for the partial pressure of oxygen. All the other numbers will be given. Okay, and it gives me at 101.3 kPa. Now, if you look at that, this sounds kind of weird. At 101.3 kPa, it's easy to just kind of look at that and go, oh, is that the pressure of oxygen? It's not, because we're asked for the pressure of oxygen. I'll come back to that. We'll talk about what it is. It says if the partial pressure of nitrogen, so that's going to be another partial pressure. So if we'll label these, the first pressure is what I'm looking for. I'm looking for the pressure of oxygen. Call that P1. Okay. P2. P2 is nitrogen. 79.10 kPa. And then it says the partial pressure of carbon dioxide. That's going to be P3. Partial pressure of carbon dioxide is 0.40 kPa. And the partial pressure of all the others, okay, that's going to be P4, equals 0.94 kPa. And then we have P total. That's the other part of the equation. We don't have a total yet, do we? Well, actually, we do. This number up here, 101.30 kPa, that is the air pressure. It says at 101.3. That means the air pressure is 101.3 kPa. Normally on a quiz, on a test, any problems that you're expected to do by yourself, I'm going to be a little more clear about that. So it would say at an air pressure of 101.3 kPa. Or maybe it would say the total pressure is 101.3 kPa. Or it could say the pressure of the mixture is 101.3 kPa. Bottom line, if it's saying that the pressure of the mixture, the pressure of all of the gases, the pressure, the total pressure, or if it says the air pressure, that's all talking about total pressure. It's very important to identify if you're looking for total pressure or if you're looking for a partial pressure. If it says I'm looking for a partial pressure, like it does in this problem, I'm looking for specifically the partial pressure of oxygen, then I need to make sure that I know what the total pressure is. It's going to be given. It might be kind of hidden, or it might say the pressure of the mixture or the air pressure. Okay, so our total pressure is 101.30 kPa. Okay, and we could work our problem now. P1, it's our unknown, plus 79.10 plus 0.40 plus 0.94 equals 101.30. Okay, so now we just need to add up what we have here on the screen, these numbers, and we're going to subtract them from this. So what we end up with, we're going to have P1 plus, and when we add 79.10 plus 0.40 plus 0.94, you get 80.44 equals 101.30. Right now I have P1 plus 80.44. I want P1 by itself, so I'm going to subtract 80.44 on both sides. So P1 equals 101.30 minus 80.44. Let's do that in calculator real quick. 101.30 minus 80.44. You get 20.86 as your final answer. P1 equals 20.86. Let's check our units. It's kPa. One thing to note right here, if you ever come across a problem where you have different units of pressure, you have to make sure that you make them the same unit. So you'll have to do a little bit of conversion, but that's the only case where you'd have to do that. So that's it. That's Dalton's law. Now you can do a little bit of practice with it. Make sure that you know how to solve problems like this one.